Stop humming. I can't concentrate.
Dad, you're never going to figure that thing out.
Quiet. Ugh.
Why don't you just call him?
I don't need his help. And I don't need more humming.
Fine, have it your way.
Where'd that kid come from anyway? Hey, it's Doc. I was hoping you could help me out. Can't seem to make this work. Huh? Yeah. Spider-Man again. Hi, welcome back. In this episode, I'll be making some tentacles for a custom Mego figure of Otto Octavius, also known as Dr. Octopus or Doc Ock. The look of the tentacles are varied based on the source material, but I decided to go with a more traditional tentacle like the original comics, but with the more aggressive claw closer to the 2004 Spider-Man 2 movie. I'll be showing the sped up 3D modeling process and giving commentary along the way. Let's get started. The program I'm using here is SketchUp. I started with a single segment of the tentacle that will be duplicated over and over to make the whole of the tentacle. I started working before I recorded, so I'm recreating the segment here, but we'll go back to the original. When I thought I was happy with the segment, I created a component of it. If you use a component over and over and then decide to make a change to that piece, instead of changing each and every one, you will have to just make the change to one of the components, and that change will be duplicated to all of the instances of that component. This is very handy and a huge time saver. After the segment was done, I started out making a straight tentacle as if it were striking, and also checking how easily the pieces are going to line up. I decided to make a 180-degree curve next. Before I started, I bent a wire next to a Mego figure to get the approximate shape before modeling it. That way I could measure the diameter of the half circle and create that in the program so I have some guide to follow. I make a couple more curves after that, all pieces of the tentacle. Then I started on the claws. The claws will be components too, so if changes need to be made to one, it will be made to all of them. Since they will have 3 fingers, I start with a triangle and kind of eyeball the shape and size I wanted. When making pieces in SketchUp or in any 3D modeling tool, it's a good idea to group the pieces so they won't permanently attach to other parts when moving them around. This way, they move and rotate independently without affecting other parts. I added some detail to the claws to make it look like they were more mechanical and interesting. You may notice I use a component piece for the middle of the claw. I then had to modify it, but before I did that, I made it unique, so changes to this segment would not affect the other segment components. If you watch closely, you'll see that I'm having some issues in different places, like getting blasted into outer space because my zooming wasn't as accurate as it should have been, or filling a simple space becomes an ordeal because the rectangle isn't all on the same plane. Also, trying to angle a claw segment perpendicular to the main segment goes a bit awry. After I had the one claw done, I wanted to vary the other three with a progression of a claw gripping at something. I start by making a copy of the first one. When I designed the first one, I included an internal knuckle joint. When I rotate at that spot and the insides are revealed, the knuckle joint will be exposed, making it look like it has some internal parts and not just a split between the two finger segments. Once I have the angle of the claw fingers, I copy that, rotate it, and place it on the other two fingers. I realized I wanted each tentacle to be able to rotate in a couple spots. That means I would need individual parts to fit together. I made a male and female end resembling a key and socket. By inserting the key into the socket, the pieces would stay together, rotate, and also be taken apart. This helps the tentacle be much more articulate. The end of this clip seemed to get corrupted, but here's a picture of two finished tentacle parts. Note the key and socket which join together. Also note the tabs on the segment which need to be aligned when putting together the tentacle parts or taking them apart. Going into the modeling program, I had no drawn up plan, just a couple quick sketches, the wire to test the shape and curves, and an idea of what I wanted. A detailed plan would have saved some time in the modeling portion of this project. The sped up video shows about 2 hours and 50 minutes of 3D modeling, but I did pause the recording sometimes to stop and think a bit. After the recordings, there was test printing, some time consuming design changes, some tweaks in the slicer, and more test prints. I'm calling these tentacles good and I'm shipping them off to the good doctor. Be on the lookout for Casual Crafter's upcoming Doc Ock custom and see the tentacles in their entirety.